welcome back. Today we are going to be talking about combat robotics. This is a brand new hobby that I've just got myself into, and I wanted to share my first robot build for the 15-pound fighting class with you guys. And rather than you have to sit there and watch me figure out each piece by piece and part by part, I went ahead and I built the whole robot, and then I completely broke it down because I need to reassemble it and have it battle ready, which means adding Loctite and just making sure things are tightened down. So what I'm going to do is a little tutorial on how I built my robot, and I will add, that video so you can see the parts done, and I'll explain to you how the parts were made, and we can just go from there. So here we go. Now, with this being my first robot, and I've never competed in a robot competition before, I'm sure there's some things that I'm doing that could have been done better, and I'm going to find all that out whenever I go to my first competition at the Orlando's Maker Faire in 2018. They already have over 100 robots registered, so there's going to be a lot of competition there. So don't judge by what you see. I'm just showing you how I did it, and maybe you can pick up some ideas from me, and maybe you'll have some suggestions for me. So let's get into the build. Okay, the first part of my build that I'm going to show you is the weapon bar. And what this is just a piece of 2-inch by 1-inch aluminum square stock that I drilled out using a hole saw and inserted a piece of pipe in there, welded it up with an aluminum welder, and then it just so happens that the inside diameter of that aluminum pipe was the exact size of my motor that I was going to use for my weapon. Now the weapon motor, let me see if I can get it out, it's in there pretty tight. The weapon motor is a cheap motor I got off of Amazon that came with the speed control. It is, I don't know if you can see it, I'll try to get it close. But it's a BL motor, 4 poles, 2150 kV motor. It's for like remote control trucks such as monster trucks and so forth, and it also came with this speed control, which is supposed to be rated around 200 amps, but because it was so cheap and it's just an off-brand, I doubt it'll go that high, but I don't need it to. So, and then here's the pipe that I welded in to my 2x1 stock. And then right here I just drilled out some 1/2-inch holes, and I pressed in some bushings, and you'll see what the bushings are for later, but I have them on either end. Alright, so we'll just stick this back in there. Now this is just a piece of 1/4 inch by, looks like 1.5 inch stainless that I'm going to use for a spinning bar on my weapon. And what I did was I just drilled a hole in the stock, stuck a 1/2-inch bolt through it, put a weld all the way around, and that's going to act as the shaft for the weapon. And that's where the first set of bushings come into play. It just slides on. Throw some spacers in there. This just slides on in such a way, and then that's going to be backed up with this pulley here. I'll connect this, which I have a beefier belt. This was just a test belt. It'll connect onto here, and that will spin my bar. Hopefully quite fast and devastatingly, but we'll see. So now they can all be lined up. Alright. Well, what I chose to use for my drive motors were these cordless drill 18 volt motors from Harbor Freight. They're pretty commonly used. They're cheap. I got one for $15 because it didn't have a box, and I got the other one for $19.99 brand new with the box. And I even bought a backup just in case one burns out for whatever reason. And there's a lot of tutorials online as to how to modify these. Has to deal with putting grub screws or set screws inside 4 of these holes to lock everything down. But that's what I used. And then here's an actual motor assembly. And you can see these mounting blocks. I downloaded this file from Thingiverse, and it's actually designed for the Harbor Freight drill motors to be used in robotics, and it just gives you a way to clamp it down to your base plate. Now this one just slides over the motor. This one has a groove in it for the for this little groove right here on the motor to slide into, and then you just bolt it up with the 2 screws on the front. And that gives you a good, solid, stable platform to mount your wheels to. And now we can talk about wheels. For my wheels, this is a HDPE or high dense polyethylene. It's a very durable, flexible plastic. I just used a 4-inch hole saw and cut these out. Let me pull this out real quick. And there's a million different ways to do wheels. I've done a ton of research online, and a lot of people, you can use store-bought or pre-bought, but I try to make as much of my own stuff as I can. Do it from scratch. And so this is what the plastic wheel looks like after you drill it out with just the hole saw. You can tell it's still rough. And then what I took is I had a piece of round stock, which is just like a 3/4 inch round stock, and I got myself one of those mini lathes from Harbor Freight that I bought years ago, and I put it in there. I drilled a hole out the center. I turned this side down so the washer would slide onto it, and then I drilled a hole through and tapped and threaded these holes to act as set screws to lock down on the motor. And then I drilled 2 holes in the washer to actually lock down on the wheel. So this just slides into here. And then you can just bolt your slide your bolts through. And that will allow me to lock the wheels on to keep them from spinning on the shaft. Just basically a home built hub is all it is. So that's what I'm using for my motors. And the thing with the plastic is real slippery, doesn't get a lot of grip. So what I ended up finding was this used to be part of a 3-inch sewer coupling. I'm going to see if I can find the middle piece so you can see what I'm talking about. Alright, I couldn't find the other piece, but this is the other wheel, and you can see this, you're never going to see that, but it says Fernco Inc. Part number is 1056-33. And what this is it's a rubber coupling, and there's a big piece in the center here that connects these two, and it's just used in plumbing. You slide it over a pipe on each end, and it has a metal band clamp that comes around here that you clamp down on the pipe, and it just forms a flexible seal when you're doing plumbing work. Well, I noticed that it had this groove pre-made in there, and I noticed that that groove happened to be the same width as my HDPE. So I cut those off, flip them inside out, and my wheel pops right into it. And if you're wondering the actual diameter of this wheel, it's a 4-inch hole saw, but the coupling is actually a 3-inch rubber coupling. So it has kind of a tight fit, but I am going to have to run a bead of super glue in here just to hold it down so it doesn't slip off or pop off while I'm getting thrown around and beat up. So that's how I made my wheels. Just like so. Alright, so now we need a body to mount all this to, and this right here is what I came up with. And what this is for the actual bottom plate itself, it's just an old sign, piece of aluminum that I cut out. And then the actual side armor itself is this same 2x1 stock like this that I just split down the middle on both sides and just radius it around the corners. Now, to attach these two pieces of aluminum, I can weld aluminum, but my machine gets really hot for small aluminum like this, and I'm not that great at it, so I didn't want to risk burning it up. So I just went the pop rivet way. Installed these pop rivets to hold the bottom plate on, and in the corners I added some little angle braces since I didn't have a lip down here to attach these two on to make that radius turn right there. I had to cut this lip out to actually get the bend. So I just took little pieces of sign and bent it 90 degrees and put a rivet here just to hold the corners down. And then this is actually my top plate, which is made out of the same sign material. And the way this is going to work is I rolled up these two edges down here on the front. And the way this armor top goes on is it's going to actually slide underneath this piece like so, and then this will bolt down. And then what these are, this is actually an active wedge and connected by a hinge. So when the robot, let me turn this down. So when the robot's on the ground, as I'm going over bumps and stuff, this thing will have the ability to pop up or move, and it keeps it right on the ground to give me the best chance of getting under the opponent's robot. And that's just attached with a simple door hinge. And of course there's one on each side. So that's it for the body. Just real simple, cut out with basic tools, all done in my garage. And for attaching the top, if you can notice, got these little holes drilled in. I actually drilled and tapped all these holes, so when the top plate sits on, I'll just run little bolts through here and just screw the top on. And now we're going to get into actually doing the assembly itself, and you can kind of see how all these parts go together.